What's up everyone? Welcome to this new video where we'll be discussing Azure's AKS clusters and workload security. We will have a closer look at the end-to-end best practices to increase the security posture of your Kubernetes containerized apps from the development stages to workload runtime, passing by laying the solid foundation for secure AKS environments. Before we get started, I would like to say a huge thank you to Joe, my former colleague from Ireland, and his fellow MVP, Thomas, for launching this year's Azure Spring Clean, alongside all the other people contributing to this community-driven event. This video is coupled with a blog post to give you detailed insights on our subject at hand. Please go check it out at this location. Microsoft's Azure Kubernetes Service is one of the most popular managed Kubernetes platforms. As it is the case for any Kubernetes environment, securing AKS clusters is the responsibility of the Azure customer. Kubernetes ecosystem security best practices apply to all clusters, regardless where they are hosted, be them on-prem or in public cloud. However, AKS has some platform-specific requirements that the operators and developers must consider to ensure that their clusters and workloads are protected from malicious attacks and breaches. Before diving in, the different options and tools we have at our disposal to augment the security posture of our containers platforms, I will briefly introduce some key concepts. Kubernetes security is most effective when it is comprehensive and starts from the early phases of building container images, pushing them to centralized private image repositories where they are scanned for vulnerabilities and compliance issues, to running them in your cluster. Therefore, securing your Kubernetes environments transcends beyond cluster and the workloads they are running. It falls in a wider DevSecOps practice where all the components used to deliver containerized applications need to be secured and locked down. For example, the CI/CD pipeline, the container image build and ship, clusters design and configuration, nodes and pods networking, applications design and build, and finally, containers runtime. Security is the concern and responsibility of everyone in the organization. Each individual and team working together to deliver infrastructures and containerized applications should adopt security-minded practices. Devs should make sure that the container-based images they are using to build their applications on are secure and compliant. We will see later what this means, and we'll take a look at some of the tools and actions they can leverage to achieve this. Ops needs to ensure that they build and operate AKS clusters following the best practices we will cover in the next section. SecOps will contribute by defining policies and enforcing them using the tools and options best suited for containers. We will have a look at these in detail in a bit. Another important aspect of securing the cluster is to minimize the attack surface. The attack surface is the set of all possible ways the cluster can be attacked from. The more complex the system, the bigger the attack surface, and therefore the more likely it is that an attacker will find a way in. In the following diagram, we will see the different Kubernetes components that are vulnerable to attack and therefore need to be protected with the appropriate tools and security options. For instance, the worker and the node VMs, the Kubernetes API server, the etcd database, the kubelet API, the containers used for applications through vulnerabilities or mounted volumes, the application code running within the applications and containers through vulnerability exploits. To achieve this, you need to implement or apply controls and configurations and best practices to mitigate all these potential modes of attack, and therefore adopt the approach of security in depth, which implies having several layers of defense against attacks on your Kubernetes cluster. If you're relying on a single defensive measure, attackers might find their way around it. Throughout this video, you will see how you can do this for each specific component. The following diagram depicts the kind of layered defense mechanisms you should be using to protect your AKS environment as a whole. For example, securing the API server authentication and authorization, securing ingress and egress traffic from and to your cluster, securing container images, securing secrets and connection strings in your applications, securing network isolation of pods and app resources, and finally, securing pods and pod capabilities. Now that we had a look at these key concepts, let's move on to AKS security in action. Let's look at the ways to secure the AKS cluster. Making AKS clusters more secure requires their design to be baked in security. Understanding the fundamentals of Kubernetes security and specific AKS security options before creating clusters will make it easier to secure and manage them. Some of the critical AKS security features can only be enabled at cluster creation phase. In the case of existing clusters initially created without those features, it is highly recommended to build new clusters and migrate existing workloads into them. It is a best practice to automate the creation of AKS clusters, thus ensuring consistent configuration across all clusters and the same level of protection. Building all the clusters in the dev, staging, and production with the same security settings will help achieve the following. Test the security posture of a cluster and its workload before moving to the production environment as they are executed on identical environments. Ensure applications running on clusters with those settings will still function as expected by the time they are deployed to production. Here are the options available to secure an AKS cluster. Enabling Kubernetes RBAC, enabling API server firewall, blocking pod access to host VM, increasing node security, turning on audit login, upgrading AKS clusters, and managing Kubernetes secrets. Let's look at these in detail. First, enable Kubernetes RBAC. Kubernetes role-based access control allows controlling authorization for a cluster's API server or control plane. This applies to users and to workloads in the cluster. AKS offers the option of integrating Kubernetes RBAC with Azure Active Directory, which can be enabled at any time for a cluster. With Azure AD integrated clusters in AKS, you use your existing user and group accounts to authenticate users to the API server. Please note that Azure AD AKS integration can only be enabled when you create a new RBAC enabled cluster. You can't enable Azure AD on an existing AKS cluster. The second option of enabling API server firewall. In Kubernetes, the API server receives requests to perform actions in the cluster, such as to create resources or scale the number of nodes. The API server is the central way to interact with and manage a cluster. To improve cluster security and minimize attacks, the API server should only be accessible from a limited set of IP address ranges. By default, your AKS cluster's API server is exposed on a public IP with no restrictions. To add a layer of filtering until AKS private clusters go GA, you can use API server authorized IP address ranges to limit which IP addresses and CIDRs can access the control plane. These IP address ranges are usually addresses used by your on-premises networks through ExpressRoute or site-to-site VPN or public IPs. This feature only works for new AKS clusters that you create. The other option is to block pod access to host instance metadata. The Azure VM instance metadata endpoint, when accessed from an Azure VM, returns a great deal of information about the VM's configuration, including, in some cases, Azure Active Directory tokens. This endpoint is accessible to any AKS container on the node by default. Most workloads will not need this information, and having access to that information can carry substantial risks. To disable this access, add a network policy in all user namespaces to block pod egress to the metadata endpoint. AKS nodes are Azure virtual machines that you manage and maintain. The Azure platform automatically applies OS security patches to Linux nodes on a nightly basis. If a Linux OS security update requires a host reboot, that reboot is not automatically performed. You can manually reboot the Linux nodes, or a common approach, and the preferred one, is to use KureD, an open source reboot daemon for Kubernetes. KureD runs as a daemon set and monitors each node for the presence of a file indicating that a reboot is required. Reboots are managed across the cluster using the same cardon and drain process as a cluster upgrade. So as you can see, you are responsible for ensuring that your worker node VMs are patched, those patches are working properly, and that your VMs are secure. It is highly recommended that you turn on Audit Login. AKS Control Plane Audit Login is still in preview. However, you can turn it on to help you do this following. Keep a chronological record of calls that have been made to the Kubernetes API server. Audit Login to investigate suspicious API requests. Those requests can be in the form of messages with forbidden or authorization failure. So these can indicate that there is an attacker trying to abuse stolen credentials, for instance. Also, turning on the audit login help you collect statistics and create monitoring alerts for unwanted API calls. Another way to improve your cluster security is to continuously upgrade to the latest non-in-preview Kubernetes version. This will ensure that you get the latest security patches, features, and updates. Azure provides tools to orchestrate this upgrade. In this process, the nodes are cordoned, and then no pods are scheduled to them. After that, they are drained and upgraded. There is another approach that I prefer, which is the disposable infrastructure approach, which means that you build new clusters, move the old cluster workloads to them, then direct users to the new clusters. This is very beneficial in the way that it lets you integrate new features to your clusters, especially those that can only be enabled at cluster creation time. Also, it helps validate that your workload's code and configuration is compatible with the new Kubernetes version, and you can remediate if needed. Also, it helps you build solid and continuously improved infrastructure as code pipelines to test and improve these pipelines on a regular basis. And finally, to build confidence in your workload deployment pipelines. The last option we will cover in securing the cluster is to manage Kubernetes secrets. There are two options to store and secure secrets, connection strings, and certificates in AKS. By using the default mechanism for configuring and maintaining secrets via the secret object model, or by choosing not to keep secret information in your cluster, but in Azure Key Vault. As of today, there isn't a native AKS integration with Azure Key Vault. However, the Azure team has been developing Key Vault Flex Volume, which is a solution that provides seamless integration with AKS. If you integrate Azure Key Vault with an AKS cluster using a Flex Volume, the Flex Volume driver lets the AKS cluster natively retrieve credentials from Key Vault and securely provides them only to the requesting pod. You can use a pod managed identity, which we will cover later in this video, to request access to Key Vault and retrieve the credentials you need through the Flex Volume driver. Azure Key Vault with Flex Vol is intended to use with applications and services running on Linux pods and nodes. After discussing the measures and options which help you make your clusters more secure, let's see how to secure the container images that will be used on these clusters. The different options you can use to secure your containers are to build secure images, secure the container runtime, and use a containers security solution. The first two options are more focused towards the devs teams responsible for building containerized applications. And the last one is an enterprise-wide solution for managing the lifecycle of those applications and ensuring that they are secure and compliant with a set of policies. Kubernetes workloads are built around container images. Ensuring that those images are difficult to exploit and are kept free of security vulnerabilities should be a cornerstone of your AKS security strategy. Following a few best practices for building secure container images will help you minimize the exploitability of running containers and simplify both security updates and scanning. Images containing only the files required for the application's runtime make it much more difficult for malicious attacks to compromise or exploit the containers in your cluster. You can achieve this by adopting the following guidelines. Use a minimal, secure base image. Only install tools needed for the container's application. Debugging tools should be omitted from production containers. You can leverage multi-stage Docker build for this. Remove the package manager from the image in a later build step. And finally, keep your image up to date, both the base image and any third-party tools you install. Another way of attacking the cluster would be to break out of the container and try to get access to the host itself, to read data of other containers or the configuration of the kubelet in order to further attack the cluster and get escalated privileges. You can mitigate this by leveraging the following common security context definitions. Allow privilege escalation, for instance, defines if the pod can assume root privileges. Design your applications so this setting is always set to false. Linux capabilities let the pod access underlying node processes. Make sure to assign the least number of privileges needed. SE Linux labels is another option, which is a Linux kernel security module that lets you define access policies for services, processes, and file system access. Again, you can use this to assign the least number of privileges needed. In the diagram, you can see an example of leveraging those security contexts. The last three lines tell you that we force the pod or the container to run as a user, not as a root. Also, we do not allow privileged escalation. And finally, we force the read-only root file system in order to forbid any data to be written to the host. Another option to secure pod access to resources is to use Azure AD Pod Identity. A managed identity for Azure resources lets a pod authenticate itself against Azure services that support it, such as storage or SQL Server database. The pod is assigned an Azure identity that lets them authenticate to Azure Active Directory and receive a digital token. This token can be presented to other Azure services that check if the pod is authorized to access the service and perform the required actions. This approach means that no secrets are required for database connection strings, for example. The simplified workflow for pod managed identity is shown in the following diagram. With a managed identity, your application code doesn't need to include credentials to access a service, such as Azure Storage, as each pod authenticates with its own identity. So you can audit and review access. If your application connects with other Azure service, you can use managed identity to limit credential reuse and risk of exposure. Deploying a container security solution will help your organization gain full visibility and security across the entire application lifecycle and infrastructure, as well as centrally detect and prevent threats. Such solution would provide the following: scan image registry for vulnerabilities and compliance, integrate with CI/CD pipelines, provide container runtime protection and control, block non-compliant pods or containers, and also provide a centralized container security management. In evaluating such a solution, be sure to choose one that scans for vulnerabilities in OS packages and in third-party runtime libraries for the programming languages your software uses. To address CVEs when they are found in your internally maintained images, your organization should have a policy for updating and replacing images known to have serious fixable vulnerabilities for images that are already deployed. Images scanning should be part of your CI/CD pipeline process, and images with high severity fixable CVEs should generate an alert and fail a build. If you also deploy third-party container images in your cluster, scan those as well. If those images have serious fixable vulnerabilities that do not seem to get addressed by the maintainer, you should consider creating your own images for those tools. Another line of defense you have at your disposal is to secure the network. The first option is to limit node SSH access. By default, the SSH port of the nodes is open to all pods running in the cluster. Preventing direct SSH access to the pod from the pod network to the nodes help limit the potential blast radius if a container in a pod becomes compromised. You can block pod access to the nodes SSH ports using a Kubernetes network policy. We will see those policies later on. The second option is to restrict cluster egress traffic. By limiting egress traffic only to known necessary external endpoints, you can limit the potential of exploitation by compromised workloads in your cluster. AKS provides several options for controlling cluster egress traffic. You can look at the blog post for a detailed list of those. Another option for securing your network is to use Firewall for ingress to apps. Always use a firewall in front of your AKS load balancer to filter traffic and protect your applications from known attacks. There is an option called Azure Gateway Ingress Controller, which is generally available and allows the use of a single application gateway ingress controller to control multiple AKS clusters. You can look at more details on the blog post for this. You can also enable network policies to secure your network. The network policies, think of them as a firewall within your cluster. They help you control which component can communicate with each other. The principle of least privilege should be applied to how traffic can flow between pods in an AKS cluster. Let's say you have a microservice app deployed to your cluster and is composed of the following components: like a front end that serves web traffic, a message application that stores or lists messages, or a user application for authentication, and then a Redis database. You can configure network policies to help you protect access to only pods that require For instance, front end should not talk directly to Redis. Front end is only allowed to communicate with message and users, and message is only allowed to communicate with Redis. The last option is to deploy a service mesh. A service mesh provides capabilities like traffic management, resiliency, policy, security, strong identity, and observability to your workloads. Your application is decoupled from these operations, and the service mesh moves them out of the application layer and down to the infrastructure layer. There are numerous utilizations of a service mesh. I will talk to you about two that will help secure your workloads. The first one is to use mutual TLS, which will help you encrypt all traffic in cluster. You can use this to secure communication between specified services in the cluster, and this can be extended to ingress and egress at the network perimeter. This provides a secure by default option which no changes needed from the application code or infrastructure. The second option is observability, which will help you gain insight into how your services are connected, the traffic that flows between them, and obtain metrics and logs, especially the logs of unsuccessful attempts or connections. This will give you an idea of any malicious activity on your cluster. We looked at all the options to secure the cluster, the workload, and the networking. So what's next? There are other important security options you should consider to make your AKS more secure. The following are not globally available as of yet, and therefore are not suited for production. You can start testing these features in POC environments and get ready to roll them out once they are promoted from their preview state. I will not get into detail about them in this video, but you can check the blog post for more details. The first one is to create private clusters. The second one is to leverage pod security policy. And the last one is to leverage Azure policy for AKS. Thank you very much for watching and hope to see you in the next video.